And the last type of mirror is called a plane mirror. And those are the mirrors you're used to. So let's draw what a plane mirror looks like and why you see your reflection in it. So here's a mirror. Here's you. Checking out yo fine self in the morning. And you're wearing a top hat. Yep, that's what I always wear in the morning, top hat. Okay, then I take it off when I go to school. Yeah. So here's what happens. The light leaves your hat and it goes in every direction because your hat does specular reflection, so it goes everywhere. So some of that light leaves, hits the mirror, reflects according to the law of reflection, and goes bingo bango to your eyeball. But here's the thing. Your eye can't see around corners. Right? Like if I look forward, I can't see what's around this way. That doesn't make any sense. I can only see in straight lines. So what I can actually see is where the light looks like it comes from. It doesn't look like it comes from my hat. It looks like it comes from over here. Okay? Same thing with the light from my feet. The light from my feet goes in all directions. Some of that light goes this way, hits the mirror, obeys the law of reflection, and ends up at my eye. But my eye doesn't see the light come from my foot. The light sees, or my eye sees the light come from my, oh gosh. Oh, there we go. I didn't draw a very good line. It should be down here. From my foot. There we go. That's why you see yourself in the mirror. What happens is your eye gets tricked, gets lied to by the mirror. And so the light looks like it comes in from the mirror itself. And so when you look at a mirror, that's what you're seeing. So when I passed around and I showed you this mirror last time, you can see yourself in the mirror. What you're seeing is the light that looks like it's coming from the mirror. You're seeing that image of yourself in there. Okay. One weird thing to talk about too with images. So when you look at yourself in the mirror and you see yourself and you're like, oh, look, there I am. What's something that you've noticed about your image in the mirror? There's something about them. Yeah. Yes. When you see yourself in the mirror, you're seeing yourself backwards. So when you look at yourself in the mirror, what looks like the right side of your face is actually the left side of your face. Because your image is flipped. Because if you wave with your left hand, your image waves its right hand. Okay? So you're always seeing a backwards version of yourself. So when you look at yourself in the mirror, you don't really know what you look like. Sorry about it. Okay? All right? Almost there. Oh, past 15 minutes. It's going to be angry at me. YouTube's not going to like it. Okay. Lenses. So a couple of things with lenses, just to point out the two kinds again. So there are, again, concave lenses. But concave lenses are diverging. They're not converging. Okay? Concave lenses look like this. And there's convex lenses. And those are converging. And they look like this. So the light for these kind of lenses comes in and then bends away. Comes in and then bends away. And the light for this kind of lens comes in and bends together. Comes in, bends together. So there's a lot of similarities between lenses and mirrors, but the light goes through lenses, it bounces off of mirror.
meters. And it obeys Snell's law. All right, last one. Almost there. And then we'll take a little break before we draw things. Okay. Things to know about light. So first of all, light is what's called an electromagnetic wave. An electromagnetic wave just means it's oscillating, which means back and forth, magnetic fields. And it's caused by vibrating charges. Caused by vibrating charges. Okay? Next thing you need to know is the speed of light. I'm going to give this to you, but you need to recognize it. The speed of light is c, and it's 3 times 10 to the 8th meters per second. 300 million meters per second. That's how fast light is. 300 million meters per second. Which is very fast. That's 100,000 times faster than sound. So if it takes like a second for sound to reach you, so if I yelled at the front of the door, like the front doors, it would take you about 1 second, and you would hear it at the back of the, like by the basketball gym, wherever. That's about how far it would go in a second. Light travels like from here to like Paris in a second. Okay, so light goes really fast. Okay, this is for all light, and there is something called the electromagnetic spectrum. Okay, the electromagnetic spectrum is basically a list of light, and it's very, very specific. And I want to make sure to go through it. It starts at low frequency and goes to high frequency. But I don't want to tell you about it. I want to sing about it. Oh, yes. Oh, yes. So we're gonna do it as we go here. Come on now. Yes. Here we go.
Oh, jeez. Now I remember. I remember this poor quality.
The electromagnetic spectrum is just a name for the range of radiation. Let me tell you what they
Okay, here we go.
radio waves, microwaves, infrared radiation, visible light, ultraviolet X-rays, gamma rays.
Okay, before I continue with the song, which we will continue with the song because you need to know examples of all these, let's quickly
go through what the electromagnetic spectrum is. So here's what it is. It is radio waves, microwaves, okay, radio waves, microwaves, infrared, visible light, which we'll come back to, ultraviolet, X-rays, and gamma rays. That is the electromagnetic spectrum. Okay? That was so much fun. Let's keep going. And